So here I am, we're back. Just to review, we have the area of a triangle is the base times the perpendicular height to the base. So as I said a few times now, hopefully I'm not killing it, we're looking for that perpendicular sign. We're looking for this perpendicular sign, and that is going to help us find the perpendicular height to the base. Again, parallelogram, we're looking for the perpendicular height to the base. And for a kite, we have this, we know from kites that this is a perpendicular, the two diagonals meet at a perpendicular, it's a 90-degree angle or perpendicular. So we're really looking for in terms of the kite, we're looking for this diagonal, which is going to be a measure of our base. And we're looking for this right here, which is going to give us an idea of height. We can also, for the kite, if it's so given to us, we don't have to do it this way. If you are given the measures of each and every base and height of the triangle in there, or some idea of congruence to help you find all of the measures, then by all means we can just break it down into the pieces. So here's another kite. If we did it like this, let's suppose we're told that this is a kite, even though it's the crappiest kite you might see. Let's say this distance was 3, this distance was 4, this distance was 5. Okay, so when I say 3, let me do it in green. 3, 4, and 5. Let's say they just gave us that side there, and they gave us this distance from, and do it in a different blue. This distance from here to here was 12. This is all we need for the kite. We could find each and every one of these triangles. We have triangle 1, which is up here, and we have triangle 2, which is down here, and we have triangle, let's say 3, triangle 4. So this is just, I just broke this up. We can find it piece by piece. If this is 4 by 3, we just use our triangle formula. 4 times 3 divided by 2. So this is going to be a 6er. And by congruence, this is going to be a 6er. And this triangle right here, this terribly drawn triangle, is going to be 3 times 12, which is 36, divided by 2, which is 18. So for this example, you can really just break it up into pieces, or you can do it this way. You can find the area of each side, and then just area one side and multiply it by 2. So what would this be? This would be 6 plus 6 plus 18 plus 18. Well, 6 plus 6 is 12. Okay, so 18 plus 18. 12 plus 18 is 30, plus another 18 is 48. So this would be square units. Okay. Let me go into the trapezoid now. We're going to leave the parallelogram up there. So here is trapezoid. And this is the great construction that's so fun to make. So trapezoid has a base, top base and a bottom base, and these two are going to be parallel. So let me mark them, and let me label them: base 1, and base 2. And we also have these two sides, which aren't necessarily congruent. And we have a perpendicular height to a base. Now, because base 1 and base 2 are parallel, this perpendicular height is to both base 1 and base 2. So what's the construction we used to find the area of this trapezoid? We made a copy of this trapezoid, and we placed it right here. This is supposed to be right up against it. You might have to tilt your head a couple times to see this, but this... Shh, please, guys. This is the copy of the trapezoid. So I just so this base 1, which is from here to here, is now this copy right here. This distance is base 1. And this distance from here to here, because it's a copy and you can kind of tilt your head to the side, this is base 2. And the perpendicular height is still going to be h. Okay, I'm not even going to draw it in there. So what do we have now? What's this new shape that is twice the area of our trapezoid, right? So right, we have a new shape right here. This is twice. And you know what, let me label this. Let's label it what in dark blue. TRAP. And to be clear, this would be like this T, this would be the same, this would be like T prime. This would be R prime. And this would be A prime, and that would be P prime. I'm not gonna get that phone. But our area, our trap, the area of our trap is equal to twice of our new guy. Well, what is this? What kind of shape is this? It's a parallelogram. It's the reason that's why I left this parallelogram thing up here. So let's find the area of this parallelogram. Oops, not with that color. Let's find the area of this parallelogram. Let me go with white. What is this guy? Well, the distance from here to here is, first we go base 2 and then we go base 1. So it's base 2 plus base 1. Right? That's all one of the two measures. We need to find the area of a trapezoid. We need the total base. And what is the perpendicular height to this base? The perpendicular height is just h. So, you know what? I messed up. Shouldn't say twice. The trapezoid is equal to, let me cross this out, is 1/2. Ugh. Okay, so 1/2 of this. Okay, well, hopefully you waited till now before you got frustrated. What's the area of this double trapezoid? It's I left the 1/2 here. This is base 2 plus base 1 times the height. Or, as we've been saying in class, this is base 2 plus base 1 times the height divided by 2. So should we do an example? I think so. So let's suppose we have a trapezoid. Example, let's say this is a trapezoid. Whoops. And they give us this base length right here is 4, and this base length is 8, and they tell us the the perpendicular height is, let's say, 3. So what we do is we take let's use this formula here. We take base 2, which is either 1, right? This is completely interchangeable. We have 8 plus 4 times the height of 3 divided by 2. And that's 8 plus 4 is 12, times 3 is 36, divided by 2 is 18. So the area of this is 18 square units. And let's just think for a second, if they gave us this distance from here to here, right? If they told us that this was also, let's say they told us this was 4.5 units, it would be not too important to us to find the area. It would help us if we